So hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 217 and in this video we are continue with our exercise. We stopped in our last video with the step 11 where I explained to you that I have to check the second position pointer with the end position pointer so that I can reset the loop. Let me show you this in a diagram what I mean. That was the step where we reached where the second pointer here reached the end position, that is here, and when it reached the end position I want that the both pointers here go back to the start position to loop again and get the other numbers sorted, right? And that was our step 11, and let's continue from here and see what we have to do after I start over again, or I have to check again my next step because I'm not finished, of course. And to do so, let me check here on step 12 to see what I did. All right. The next step, what I thought is we were here in our if statement, right? So let's go back here. You can see this here is a if statement. And the if statement has here a condition. But when you think about conditions, and conditions are very, very important in programming, that you think about them, and not only one condition, you have to check actually all conditions. And this is also one place where many bugs occur, that we check not all condition. And in this little sort algorithm you will see I have made a lot of mistakes, that I not checked all conditions, and all time when I have not checked all conditions there is a potential bug in it. But let's continue here. So here you can see we have an if statement. We know our if statement has all time a conditional part here, and the if statement will only enter if this conditional part is true, which means if the first position pointer value, this one is bigger than the second one. But it is very important that you say what happens if this condition is not true. So what should happen with this pointers if let me make so if this one and this one is not bigger. Let's say in the second here, when the pointer starts here again, looping here through, because they will start all time at this point here from the start. So what happens if this is not true? At this point it is not true, and this condition, or it is called state actually in programming, this state you have to check too. And we check the state with a condition, of course. You can see this condition, if this is true we go here, and now we make just a else. So if this is not true, you can do here a else. Of course you can say here else. Let's repeat the keywords what we learned with if statements. We can use a if just as if we don't need a else. But if we need another condition, in this case we need another condition, if this is not true we can use a else. Let's do this. But we also learned we could also use here another syntax, which is else if we want to specify a condition. In my case, when I go back, there are only two conditions. First condition is that this number is bigger, that was here on top, and then it will make a swap. The second condition is it is not bigger than the second one. This is the second picture here. Then it will make not a swap. And there are not other conditions. And this is very important in programming, that you learn to see all conditions. Because like I said, if you figure out not all conditions in programming, this is all time a place where a bug will occur, which means an error in the future will occur because you check just the states which are obvious, but you check not all this, let's say, very unlikely states, but still can happen, right? In this case, both are very likely. So you have, this is very easy here to check this condition or this condition. And yes, let's do this. So, and in this case, I don't need to write else if. You could also write here else if less or equal and so on. But in our case, if it's not bigger, but in my case, I said if it's bigger, just swap, else don't swap. So let's write this one down, or let's copy this one down so I can see what I did here. I did, there are other things too. Let's write the else statement here, just so very simple, else. And now I have just to define what happens if it's not bigger. And I said, okay, if this one here, on the second one here, if the first point is not greater than the second one, I just say, just don't swap, just go to the next. Here, the pointer should just move, and the move is just, you can see, is just our step 12 here. Let's copy this one here and paste this one here. And in my last video, I said you should comment this out. Let's write here some comments. This is 12. Let's write here step 12 too first, that we can see what I did. And let's write here a comment which makes a little bit sense. Let's write here if don't need, if I I don't need swap. Let's say no need swap, no need swap, because equal or less, because that's also not, because comparison is not greater. Let's write something like that. And here I write just a comment and say pointer should just move to the next position. Pointer should just move to the next position. Okay, that's not perfect commenting, but I don't want to make to waste too much waste time here. And yeah, we go to the next step. All right, we have understand this, so I don't need swap here. They should just go here, compare. If this is greater, they should swap. Okay, let's go to 13. But you see again, I have here other codes in this else, in this step 12, which means that was also the thing what I said in my last video. This when you are developing, it is not a linear developing. Linear developing means it starts not from top to down. You are creating some parts and then you are going back and change the parts or include something, and yeah, that's also very important. And let's go to number 13. Let's see what we can see there. Where is 13? And you can see we are actually from here. I go now to 13. And interesting is this swap here is now in another if statement here. So I have included this one here. And interesting is this step 13 here. We did this already, right? And let's see, not here. Let's see in our code. We did this already. We can see this. We have this here in step 8, and step 8 I have not commented out. That was bad, but I have commented out here a little bit. It says position a little bit, check position of the swap pointer for enter condition. Yeah, that was this our 8. Let's write this also here. Check. Let's write here just check end position and position. Check end position, and this step here I repeat here. The question is why I repeat this step here, because again I told you that we have to check every condition, in this case every state. So I said right now that the pointer, if this one is here, if this one is not greater, they should just walk there. This one is clear, right? But what happens if this two pointers reached again the end condition, right? And when they reach the end condition, let's say this number here, and this number here is, let's say this number here is 1 and 1. If they reach the end condition, then they still should not swap, right? But they still have to compare. These two pointers should realize that this was the end condition. And you can see here in my else, they would just go to the next point if I would keep it here. You can see here on top, I just compare if it's greater. Here I am here in the end, and they would just go to the next, and that would cause an error here if they would go to the next step, right? And I have to avoid this kind of stuff. To avoid this, that's why I have now built in this step 13, which is again a check. Check the end position, and if it's the end position here, then you have to do this one, else you should go on. So let me copy first this one here, and let me explain what I'm doing there more in particular, because it's very important to understand. So here is our else. Let me see if I include this right. Yes. So you can see this was right at step 12, right? That was just what I wrote here. And now I say I have to check first the end position, and let me replace this one here. You can see this what I have here, I have to put it in this else statement, because this else statement here check, oops, why is that so? Because that was here, I think. Okay. Yes. No, it's right. And because now I check first if this is the end condition, and if this is the end condition, let's say again here 1, 1, they should not move on. Then the pointers, the first one and the second one, should go to the start here, to the start position. That's very important here to understand. And again, you have to check this condition. With other words, in programming, they say also state. Condition is more that what you do in programming, because this is the condition, and in general, they call it state. In which state you are, check your state, and then act towards it, right? Or accordingly. And I do this here in a condition, but careful, we have in programming different kind of condition. This is a if condition. You can use also other things like a switch and whatever. We learned this, but I use here in this case if conditions. And again, here, this is the step which I have to check, and we have talked about it. Again, I check first if this is a null PTR, because this one is a little bit strange. Why I check here at this point if this is a null PTR? Can you think about this? It's a little bit hard, but to know as a starter, but perhaps you know it. Why I have to check here as well for null PTR? You can see I said this condition here, this else here, should normally come at the end of the point, but here I check null PTR too. Normally what happens is I set my end position pointer, and it is all time checking to this end position pointer to start. But this is again a state which can happen. It's very rare, also it's not often. This state is not often, and this is the state probably when the list was sorted from the beginning. For example, if the list here, what I have, was already sorted, for example, 1, 2, 3, 4, then it would not ever swap at all, right? This is again a condition. This swap here would never activate it at all, because it checks, no problem, go to the next. It checks this one, it's still not greater than the second, it goes to next. And then this condition happens only if the list was sorted. And that's why I said you have to check really all states. And like I said, in programming, they say states. This state, and if you miss one state, and that's the problem in general programming, then that is the place where probably a bug will occur, which means just because you have not considered all possible states and have not reacted to this all possible states accordingly, then the program can make a problem, a big problem. It works not accordingly, and so on. And with that said, I want to talk a little bit more about the states, because you have to learn this again in theory. There is a state theory in programming. It's not easy. It's a big topic actually, because it is important. But in practical programming, you need this knowledge. At least you need the knowledge that you have to check every condition. I call them conditions because if one state is not covered or condition, like I said, in programming, you get a big problem. And like I said, it's a bug because you have not covered all situations what the program can be, can be executed. This is an execution process which can happen, and you have to react accordingly. The next thing what I want to talk is, of course, first of all, you have to read in theory a little bit more about states. Try to understand the states and try connect this with this practical programming here. And what I mean with practical programming is, in theory, they make all the state machines, for example, and then they explain how to go there and there. But try to connect this with this practical use case. In practical programming, this state means you have to cover all the situations, right? This is very important. And I want to talk one more thing. I think that's enough for now. I think that's enough. All right. With that said, I think we should stop here. And important is that you should try to read the states, right, in programming, why these are important. I showed you here some examples. There are this different kind of situations. First situation, let's call this here the first situation. You can see it is greater. The state will say, okay, I will swap, and then go. The second state was here. Here it starts again. It will not swap. And then there are other states. It is already sorted. Let's say 1, 2, 3, 4. It will never swap at all. And then you have to check every state. And yes, now I know what I else will want to talk to you is, you can see with the states that it is very important in programming that just watching a YouTube tutorial or listening, it's not enough. What I mean with that? I mean with that, if you understand all that what I talk here, that's very nice and very good. But this is the reason why you will not be able to program if you are not doing this on your own, if you are not really programming, because this kind of state, this kind of thinking, first of all, it is not linear. Linear means it goes not from top to down. You can see I jumped the code here and include it here. And the reason why I include this code, for example, here is because I have not covered the state, or I have not considered the state in this combination. So I had to create here a if, I had to make this else, and then you will see in future I have to change here a little bit more code. Here you can see all the screen commented out codes will states which changed during development. And this is the reason why it is not, let's say this is one reason why it is not, it will help you not alone to just watch a YouTube tutorial. And that's why I say you have to practice it on, try to make it on your own to see how you can use these conditions, how you can create this condition. Because if you understand that, okay, this is a condition, we have to do this, that makes no sense, because this condition, you understand it only when you understand why you are doing this and why the state is changing, and then how you include this. Just with listening, understanding will not work. And that's why I say all time practice. And that's why we practice this one. So I think I talk now again too much, but it's very important that you are doing this on your own, because on just with showing you this one, this will not help you. This is the thing which is, let's say this is one of the things, one of the reasons why just listening will not work in programming, to understand and be able to program, because this kind of states you have to practice and integrate in your brain how to solve this. All right, with that said, if you have any questions or any comments, like all times, write it in the comments, and see you in the next video. And like I said, read about states, very important, because if you cover not all states in programming, this is probably one place where you make a bug in your code. And with that said, bye, good luck, and have fun.